Good day. So let's continue our discussion about operations on radicals, but this time we're focusing how about different indices. So for the different indices, we can utilize the rationalizing numerators and denominators. Now, take note that in the previous discussion about our operations on radicals, we introduced this theorem, which is the nth root of A times the nth root of B is equal to the nth root of A and times B. Meaning, for example, square root of 2x times square root of y, we can directly multiply the radicand, which is 2x times y, no? Because they have the same index. Another is we introduce also this ratio, the nth root of A over the nth root of B, which is equal to the nth root of A over B, where our B should not be equal to 0. Meaning, example, the cube root of 4x over the cube root of 2x is equal to the cube root of 4x over 2x, which is equal to the cube root of 2. We can directly divide the radicand of both numerator and denominator because we have the same index. How about these examples? Can we directly? So we have the square root of 3x times the square root of 9x squared. And also the fourth root of 2m squared and to the cube over the cube root of mn squared. So to note, when the radicals have different indices, their product and quotient are obtained by converting the radicals to common index. Meaning, we have to change first the index in order for us to multiply or divide the radicals. So let's have an example for that one. How about this? No? So square root of 3x times the cube root of 9x squared. Now take note that by the laws of exponent, we can write the square root of 3x to the 3x times 1/2. And also, with the same strategy, we can write also the cube root of 9x squared to the 9x squared quantity to the 1/3. In order for us to have the same index in this problem, we have to find the LCD of the index. So our index for the first term is 2, while the second index for the second term is 3. So note that the LCD or the less common denominator of 2 and 3 is equal to 6. Meaning, we can write the expression above to 3x times 3x quantity 3 to over 6. And we can write 9x squared to the 1/3 to 9x squared to the 2x. So how does work? So if we find the LCD of the denominator or the index, is we can divide that one. No? So 6 divided by 2 is 3 times 1. So that's why you have 3 over 6. So 6 divided by 3, that is 2 times 1, then we have 2 over 6. Now we can also back to this expression into a radical form, which is 6th root of 3x quantity to the cube, meaning the denominator of our fractions here is our index and the numerator is our exponent in the radicand. So that's the rule, no, of the laws of based on the laws of exponent for the radicals. And also for this part, so we have 3 squared x squared quantity squared because the numerator here is 2 and then our index is 6. Okay, so hopefully you understand this part, which is we get the same index. Now our problem here is we have simplify, no, this part. So we have to simplify. So we have 3 to the cube, so meaning 3 to the cube, and then x to the cube is x to the cube, times 3 squared is 3 to the 4th, then x squared to squared is x to the 4th by the laws of exponent. And then, since we have the same index from the previous discussion that we have for the multiplication, if they have the same index, then we can multiply directly. No? Meaning, 3 to the cube times 3 to the 4th is 3 to the 7. Then x to the cube times x to the 4 is x to the 7. So, by the laws of exponent. Meaning, we can also simplify this one to 3 to the 6, x to the 6 times 3x. Then, the final answer is extract na to ang kanina na ay mga exponent of to the 6. So, we have 3x, 6th root of 3x. So, that's the final answer. Let's have another example in order for us to understand this part. So, we have 4th root of 2m squared and n squared over cube root of n squared. And then, so we can rewrite this one as to the 1/4 and 1/3. The LCD for the 3 and 4 is 12. Meaning, 12 divided 4 is 3 times 1. So, we have 3 over 12. Then, 12 divided by 3 is 4. Then, times 1. So, we have 4 over 12. Then, by the law, we can write this one in this term. And then, we can directly write that one into this term. So, we can get 2 to the cube, m to the 6, n to the 9. And then, by the laws of exponent, we can simplify that one, no, to the m squared n. So, because m to the 6 over m to the 4 is m squared. And then, n to the 9 over n to the 8 is n. And then, that's the final answer, which is we can simplify 2 to the cube to 8, m squared n. That's it. So, thank you for listening. See you in the next video for our additional example for operations on different indices.